Okay, well, welcome to the next chapter. This chapter is a lot of theory. There's really no math in this chapter, so that'll be nice after having got done with some other chapters that were a lot of math. So what we're going to talk about today is we're going to go back to ionic compounds, which I know we talked about way back when, but now what we got to do is look at these and go, okay, so what's exactly going on inside these molecules? And we're also in this chapter going to look at molecular molecules and some other things. So you're going to find some stuff in this chapter that's going to be a little bit of a review of stuff that we've learned before, and I hope you learned it before, because then it'll be like, oh, well, that's easy. And then what we're going to do is we're going to add some more stuff to it, okay? Which again is what I told you at the beginning of this course, that we're going to constantly keep adding stuff to things and building upon what we already know. So notes today that you should have written down and made a copy of is the ionic bonds, right? And the first thing is a thing called valence electrons. What valence electrons are is that, excuse me, goodness, that when we did electron configurations way back when, we did all of the electrons for an atom, looking at everything from the very first energy level all the way out to whatever was the outermost energy level. Well, in the case of valence electrons, all we're going to look at is just the outermost electrons. We're not going to worry about all the rest of them that are underneath it, right? The ones that are underneath, yep, they are important because they help identify that element as to what it is. But that very last set of electrons, right, they are the ones that determine the characteristics of the atom. Now, what do I mean by outermost? Well, let's do something. Let's do sodium. And sodium happens to have an atomic number of 11. So if I did this, and hopefully you'll remember this from way back when, this is 1, 2, and 3. So I got to put 11 electrons in here. So that's 2, 2, 6, there's 10. And then I get 1, and that's my last one. And notice this is the outermost energy level. That's the farthest from the nucleus. How many electrons in there? Well, there's 1. All right. So that's the only thing. We're not going to worry about all this stuff in here now. We're only going to worry about that outermost. And right now you're probably going, oh my gosh, we got to go back to making these things again? Nope. That's the awesome thing is we can utilize the periodic table to find out what this is. So I'm going to get rid of this for now. All right, so according to your notes there, it says that those valence electrons, those outermost electrons, that one electron, the outer thing, that determines many of the chemical properties of that element. Right, so that's going to give that sodium a lot of his properties, right? Really almost all of his properties. Second one, letter B, it's the electron in the outermost ring only. That's the only one we're worried about. We're not worried about the 2, and the 6. We're only worried about the 1. You're going to find that it's only between 1 and 8 electrons. That's it. We're never going to have more than that. Okay? We're not going to have 10. We're not going to have 20. It's only going to be between 1 and 8 electrons. So now, how do we figure this thing out? Well, if we go to the periodic table, which I'm going to just make a little sketch of it. And this is what you're going to have to add to your notes, is this sketch, because I did not put this in the copy of the notes. Right? And again, it doesn't have to be perfect, but I hope you can see the periodic table in this sketch. I'll show you my periodic table. Right? So when you look at this, right, you know, there's that top part, there's the thing going across. Then we got the area down below going across. Then it comes up. Right? So it's just a quick sketch of the periodic table. Well, this is the very first row, and way back when we said that first row had a positive 1 charge. That is correct. That is one way to look at the periodic table. But now we're going to look at valence electrons. And all these guys in this first row have 1 electron. That's how many they have in their outermost ring. Then we go to the second row. These guys all have 2 in their outermost ring. Okay? Then we go to the center area, and they basically, at this point, what I want you to know is that they basically have 2. Now, there's some exceptions to that rule. We're not going to worry about those exceptions. You can worry about that if you go deeper into chemistry. These guys down below, remember they're the inner transition. They also have 2 with some exceptions. Right? Then we get over to this area over here, and this very first row, they have 3. And then we get to, these guys have 4. Now, when we did charges, this so far looks very similar. It's like, well, that was plus 1, plus 2, plus 2, plus 3, plus or minus 4. But we're doing valence electrons. We're not doing charges. This is telling me how many electrons there are. So now if I go to this next one, instead of this being a -3 this time, it's going to be these guys have 5 electrons. Now, why did they have a -3 before? Well, remember before they tried to fill this up. and they put electrons in there, and they wanted to get to 8, so they added 3 electrons. That gave them a negative 3. We're just looking at how many electrons they have, so these guys have 5. Then we have this one, they have 6. These guys have 7, and the ones in the very last row over here, they have 8, with the exception of helium up here. He has 2. All right, so you're going to want to write this down in your notes. And again, this is not on the notes that were on the Canvas page, all right? But you're going to have to add this to that. And those are the valence electrons. So we can look at the periodic table. We can look at this thing and just identify where that element is on here and go, well, it's in this row right here. So that would be 7. They have 7 valence electrons. Right? That's what this tells us. So letter E, these electrons only ones are used for chemical bonds. So it's basically this 1 through 8. Those are the only ones that are going to decide how these atoms go together. Right? None of the ones underneath, inside the atom, are used for chemical bonds. So letter F, electron dot structures. I'm going to get rid of this. And so electron dot structures, we only diagram the valence electrons. We're not going to diagram all the other ones underneath. We put dots around the element symbol, so we're going to do hydrogen. Well, hydrogen's in the very first row, so he's got 1 valence electron. So what I do is I have to visualize on this hydrogen that he's inside of a box. Right? That box is not there, but basically that box has 4 sides. So now what I can do is I can put a representation of that 1 electron anywhere on one of these 4 sides. And what I do is I put a dot. Okay. So now again, this box is not there. You just have to visualize, imagine that it's there, that it has 4 sides. So now my dot could go there. Well, it could also go over here. It could also go up above. It could also go down below. It doesn't matter which side it goes on. There's no rule about that. Now we go to the next one that you're supposed to do is BE. BE, oh, there's my lights. Hold on. Get my lights turned back on. BE's in the second group, so he's got 2. So now the way this works is the electrons, remember, are negatively charged. They don't like to be next to each other unless they have to, and then they really aren't real excited about it. So they're going to go, we're going to put 1 there, and then we're going to put opposite, 1 over on the other side. Right, so that's his electron dot structure. Then we go to oxygen. Oxygen, he's got 6. Now remember, where am I getting this from? I'm going to show you real quick. All right, here's hydrogen. Remember, see, we said he's got 1. That's because he's in that very first group. BE, we said he had 2 because he was in the second group. Now we got oxygen, which is over here. So it goes 1, 2, 2, and 3, 4, 5, 6. So oxygen has 6 valence electrons. Now remember the idea that we can only put 1 on each side. So I'm going to go 1 here, 1 there, that's 2. Then 1 up here, 1 down there, there's 4. And so I got 1 on each side. Now I got 6, so now I'm going to go back. Now I can go back and put my second one in, so I'll put a second one there, that's 5, and there's 6. Right? So that's what it's going to look like. It could have 2 here and 1 there. It doesn't matter. All right, again, it doesn't matter where they go, just as long as you have that visualization of the box and they're on the 4 sides of the boxes. Right? All right, so elements adjust to achieve their lowest possible energy. What they're going to try and do is they're going to try and get themselves to look like a noble gas. Right? These electron dot structures that I showed you up here, the 1, the 2, and the 6, they don't like to be like that. That is what they are, but they don't like that. What they want to look like, they want to look like a noble gas. But what is a noble gas? A noble gas is the ones that are, I'm always looking at this backwards on my screen. These are the guys that are right here, the very last row. So they're trying to look like them. Well, according to our notes a minute ago, these guys have 8, with the exception helium has 2. Right? So what these guys are trying to do is they're all going to try and get 8 valence electrons. Right? And what they're going to do, they're either going to lose these valence electrons or they're going to gain some more, which we talked about before when we talked about ionic charges. Right? So, noble gases, it says highest energy level is filled and therefore stable. Those ones that are in that very last group over here, these guys do not like to react because they're already full. They aren't going to take electrons from everywhere. They're going to lose any. They just like float around and go, wow, I just feel wonderful. Everything's just great. Okay, because I've got all the valence electrons I need, and I'm not going to hang out with anybody else. I'm not going to join up. I'm not going to chemically combine with anybody else. Okay, so they do not react. All right, my personal next page of notes is letter H, the octet rule. How many is in an octet? 8. Or get that on the screen. Okay, so atoms react by changing the number of valence electrons to be a stable noble gas like. And what we just said a moment ago is 8 electrons, with the exception of hydrogen. And hydrogen wants to look like helium, so he's going to be 2. That's the only exception to this. So this hydrogen up here, what he's going to try and get is 2 electrons. Everything else, this guy, and all the rest of them on the periodic table are all going to try and get 8. Okay. Cation. I do always like to point out this is pronounced cation, not cation. It's cation. A cation is a positively charged ion. Why? Because it's got more protons than electrons. Now, one way in which I remember this is in the word cation, there's a T. A T looks like this, and that T then also looks like a positive. So that's one way to remember that cations are positive. Right? They tend to be the metals. So they are, remember that there was the stair step on the periodic table right here. Everything that's over on this side, that left-hand side of the periodic table, those are all metals. Those are going to be cations because they have positive charges, which we talked about way back before when we talked about ions. Anions. Anions are negatively charged. Why? Because they have more electrons than they do protons. They gained some electrons, brought some in. These are the non-metals. Right? Again, here's my stair step. So the negative ones are going to be these guys up in here. All right, those are my non-metals, and they're going to be negatively charged. All right, I'm going to stop there. I'm going to go part number 2 because I'm running out of time. So I'll see you in a minute on part number 2.